Right, here we've got some forces at angles to the horizontal and vertical, and we want to work out the horizontal and vertical component of each of these forces. This one we'll come on to in a minute, slightly different. So to do this, we're going to draw our 200 Newton force. There it is. Okay, and what we know about this 200 Newton force is it's got a horizontal and a vertical component. So it's got a vertical component and a horizontal component. But we often draw this into a vector triangle. So the way to do this is, here's the horizontal component and then there's the vertical component. And we've put those head to tail, and that gives you then the resultant. Now, the horizontal and vertical component are at 90 degrees to one another. We know this angle here is 30. This then forms a right angle triangle. So here's your hypotenuse, your adjacent, and your opposite. So in each case, we know the hypotenuse. We want to work out the adjacent and the opposite. The adjacent being the horizontal component, the opposite being the vertical component of this force, okay? So any force that you've got, you can split it into horizontal and vertical components. Or more, I suppose it would be more accurate to say you can split it into two components that are at 90 degrees to one another. 90 degrees to one another. They don't have to be horizontal and vertical. It could be on a different in a different direction, I suppose. So to work out these ones though, we're going to use trigonometry. So initially, we've got here, we want to work out the horizontal component, which is the adjacent. We've got the hypotenuse, so we're going to use cos. So we know that cos of 30 is equal to the adjacent over 200. So this horizontal component now is going to be 200 cos 30. Okay, and 200 cos 30 gives you 200 cos 30 gives you 173. So 173 newtons, okay? So that's the horizontal component there. Now, the vertical component is the opposite. So in that case, you're going to use sine. So sine of 30 is equal to the opposite over 200. And therefore, the vertical component here is 200 sine 30, which gives you 100 newtons. Okay, so that's that one done. We know the vertical component and the horizontal component. 173 and 100. Right, we can do the same thing with this one. So this time we can split this into horizontal and vertical components. So we could say, again, there's our 350 Newton force. Okay, and we're going to split this into horizontal and vertical components. So head to tail, 40 degrees there. So again, this is the opposite. This is the hypotenuse. This is the adjacent. So to work out the horizontal component, we're just going to do 350 cos of 40. And to work out the vertical component is 350 sine of 40. Okay, that gives you 268, and this gives you 225. All right, so that's how we do that one. This one, slightly different now because the angle is between the vertical and the force. So if we draw this one as follows, so we're going to have, there's our 3.75 Newton force, and we're going to split that into a horizontal component and a vertical component. Now, we know that this angle here is 47 because that's the angle between the vector and the vertical. So to work out in this situation now, we're going to it's going to be slightly different because this is now the adjacent and this is the opposite. Whereas before the adjacent was the horizontal component, now the adjacent is the vertical component because we've got the angle between the vertical and the vector. So this time it's going to be 3.75 cos 47 for the vertical component and 3.75 sine 47 for the horizontal component. And if you work that out, you're going to get the following: 3.75 sine 47 gives you 2.74 newtons, and 3.75 cos 47 gives you 2.56 newtons. So you notice that was the three significant figures, both of those three significant figures. So there's your answers there. Right, this final one, we've got this vector here of 25 meters per second, so it's a velocity, and we know the horizontal component of that vector is 15 meters per second. And what we're trying to work out now is, what is the vertical component of this vector? So we've got 25, and we know that this one is 15, and we're trying to work out what is this one here. Okay, so this is the hypotenuse, and we're going to work at this angle here, theta, so that would be the adjacent and that would be the opposite. So these two vectors here, the horizontal and vertical component of this vector, form a, well, they are at 90 degrees to one another, so therefore we get a right angle triangle. So we can use Pythagoras theorem again. This time we know that this vector here is going to be 25 squared minus 15 squared, and then we're going to square root it, okay? So when you work that out, you're going to get 20 meters per second for your answer. And then the angle, well, we know the adjacent, we know the hypotenuse, so we can use cos theta here, okay? So we know that cos of the angle is equal to 15 over 25, and therefore theta equals cos the minus 1, 15 over 25, which equals 53.1 degrees, which I'm just going to quote as 53 degrees because both of these were two significant figures, so we'll make this two significant figures. Okay, so there you go.